Okay. So in chemical equilibrium, basically we have two types of reaction. And the first one is basically called irreversible reaction. And the second one are called reversible reaction. And they normally ask the definition of a reversible reactions in exam. So, okay, we all know that the reversible reaction, the reactions that only goes in one direction. Okay? And the reversible reaction, the reaction in both directions, that is forward and backward. Okay? So these are called a reversible reaction. As an example, if we take an example of any journal reaction, like take an example of an acid-base reaction. If you have HCl reacting with sodium hydroxide and it forms sodium chloride and H2O, water. Okay, this is a neutralization reaction. And you can see this is a reaction which is a irreversible reaction. Okay, we cannot predict which reaction is a reversible reaction or which reaction is an irreversible reaction just by looking at the equation. Okay, if the equation is represented in a reversible or irreversible manner, like उसकी arrows से आप उसका पता लगा सकते हैं. Let's suppose the most famous reversible reaction is the nitrogen reacting with hydrogen forming 2NH3, which is ammonia gas. Okay? You know that this is the reaction Haber's process. A reversible reaction is represented by a double-headed arrow. A irreversible reaction is represented by a single-headed arrow. ठीक है? यानी आप किसी भी केमिकल रिएक्शन को देख के खुद से नहीं पता लगा सकते कि इरिवर्सिबल है या रिवर्सिबल है until or unless the equation is given, and if in the equation you have a reversible sign given, then it means that this is a reversible reaction. ठीक है? इस में याद रखिएगा कि इस डायरेक्शन में this is called the forward direction and ये वाला क्या कहलाता है? This is basically a backward direction. ठीक है? और ये नॉर्मली टू एरोज से भी आप रिप्रेजेंट कर सकते हैं लाइक दिस, और यू कैन रिप्रेजेंट इट बाय अ half headed arrows as well. Okay, so this is the definition, and they normally ask the definition of a reversible reaction, so you should know that the reaction that goes in both direction, forward and backward, are called reversible reaction. Haber's process, contact process is the most common example. In a reversible reaction, there's a condition which is called dynamic equilibrium. Dynamic equilibrium. Okay, देखें, initially, if you have a reversible reaction, let's suppose you have a reaction between A and B, and this is forming C plus D. Okay, this is a reversible reaction. Initially, you can see that the rate of forward reaction should be maximum. And if I ask you why initially the rate of forward reaction is maximum, because you have the maximum amount of A and B is present. As time proceeds, जैसे जैसे time गुजरता जाएगा, reaction होता जाएगा, the rate of forward reaction decreases, and in a similar way the rate of backward reaction increases. So at time zero, or the initially when you just added up reactant A and a B, the rate of forward reaction is maximum and the rate of backward reaction is zero. और जैसे जैसे time बढ़ता रहेगा, the rate of forward reaction decreases because the reactants are getting used up. Rate of backward reaction increases because product form होती जा रही है, and is a condition at which the rate of forward reaction becomes equals to the rate of backward reaction. That's called the dynamic equilibrium. ठीक है? तो अगर हम इसको ग्राफिकल वे में रिप्रेजेंट करें, so let's do it in a graphical way first. देखो, if this y-axis is the rate of reaction, ठीक है, and this is time. At time 0 the rate of reaction is forward reaction is maximum. फिर ये कम होते 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 rate of backward reaction, I'm going to represent it with the okay. Now हो क्या रहा है, this is basically a forward reaction. Initially the rate of forward reaction is maximum, जैसे जैसे टाइम गुजरता जा रहा है वो डिक्रीज होता जा रहा है, and this is the rate of backward reaction. On this graph, this is a condition or this is the area where the rate of forward reaction becomes equals to the rate of backward reaction. This is basically called dynamic equilibrium. Dynamic equilibrium. So if I ask you define dynamic equilibrium, तो आप क्या कहेंगे? In a reversible reaction, when the rate of forward reaction becomes equals to the rate of backward reaction, it is called a dynamic equilibrium. So I'm just going to define dynamic equilibrium. Going to give you the definition here. The condition in a reversible reaction when the rate of forward reaction is equal to the rate of backward reaction. Okay, this is called dynamic equilibrium. Clear? And when the rate of forward reaction becomes equals to the rate of backward reaction, there should be no change in the amount of reactant and there should be no change in the amount of product. यानी जो rate of formation of product or decomposition of product same हो जाता है. Clear? The amount or the concentration of reactants and products is constant. ठीक है, एक कॉमन एरर है बेटा, कॉमन मिस्टेक ये करते हैं बच्चे कि वो कहते हैं कि डायनेमिक इक्विलिब्रियम the concentration of reactant and product becomes same. It's not same, it becomes constant. If I give you an example of a Haber's process, सिर्फ 17% अमोनिया फॉर्म होता है एंड देन डायनेमिक इक्विलिब्रियम अटेन हो जाता है. ठीक है, बात समझ आ रही है? तो इट मींस दैट at dynamic equilibrium whatever the concentration, उनका 50-50 होना भी जरूरी नहीं. It's not necessary that you have 50% reactant 50% product. It could be any condition, it could be any concentration of reactant and product, but they become constant. ठीक है ना? यानी if you have a Haber's process N2 gas plus 3 H2 gas, it's a reversible reaction. The concept of dynamic equilibrium, it's only for a reversible reaction, forming 2 NH3 gas. Okay. Now, the condition which is used for the formation of ammonia is basically the same condition for the decomposition of ammonia. That's why it's a reversible reaction. यानी जब आप नाइट्रोजन हाइड्रोजन को मिक्स करते हैं to form ammonia, you provide a temperature of 450 degrees Celsius. That temperature and the pressure of 200 atmosphere is basically the condition for the decomposition of ammonia as well. तो अमोनिया फॉर्म भी हो रहा होता है और डिकम्पोज भी हो रहा होता है. We say that a reversible reaction is taking place. ठीक है? So as जब भी dynamic equilibrium attain हो जाएगा, so if you have like 1 mole of ammonia जैसे ही फॉर्म होगा 1 mole of ammonia decompose हो जाएगा. So क्या आपको कोई चेंज मिलेगा इन द अमाउंट ऑफ प्रोडक्ट? नो. ठीक है ना, because the rate of forward reaction, the speed by which the ammonia is formed, and the rate of backward reaction, the speed by which ammonia is getting decomposed, become same. ठीक है, clear? If I ask you, or if I represent the same thing on a graph, ठीक है, so this is the graph that I am sketching about, you can say amount. Amount could be concentration as well. ठीक है, and here you have time. So क्या होगा, इनिशियली द अमाउंट ऑफ रिएक्टेंट इज मैक्सिमम, और फिर वो कम होते होते एक पॉइंट पे आके इट बिकम कांस्टेंट. सॉरी, दिस इज द अमाउंट ऑफ reactants, and this one is the amount of product. प्रोफाइल समझ आ रही है? रिएक्टेंट इनिशियली मैक्सिमम थे, जैसे जैसे रिएक्शन प्रोसीड करता गया कम होते गए और फिर कांस्टेंट हो गए. प्रोडक्ट इनिशियली जीरो थी, ठीक है, दिस इज, यू कैन अज्यूम दिस इज जीरो, एंड दिस टाइम प्रोसीड इट बिकम constant. Now, roughly, this is the region where you can see the amount of reactant and product become constant. This is basically called dynamic equilibrium. Okay, this is called dynamic equilibrium. Amount of reactant and product become constant. Okay, Beta, so I hope the point is clear that one more thing about, for dynamic equilibrium, a closed system is required. इसका क्या मतलब हुआ? Means if you are constantly adding reactant, varying the temperature, pressure, then you won't be able to get the dynamic equilibrium. Dynamic equilibrium के लिए the system must be closed. Nothing should be going in, nothing should be coming out of the system. ठीक है? So if I just give you a review about the three conditions of dynamic equilibrium. Conditions. Okay, number one, rate of forward reaction is equals to the rate of backward reaction. ठीक है बेटा, this is the first condition. Second condition, concentration of reactants and products is constant. And the third and the last condition, a closed system is required. ठीक है? A closed system is required. So these are the three conditions that must be present when you have a dynamic equilibrium. The first condition, the rate of forward reaction and the rate of backward reaction becomes equals, the concentration of reactant and product become constant. ठीक है? And the third condition, it only happens when you have a closed system. As soon as you have an open system means you add something, ठीक है? You remove something, you vary the temperature, pressure, then the dynamic equilibrium get this. ठीक है, यहाँ तक बात समझ आ गई? So just a quick review. Yes, there are two types of chemical reaction: irreversible reaction that goes only in one direction, Reversible reaction that goes in a both direction, that is a forward direction and a backward direction. Or in a reversible reaction is a condition at which the rate of forward reaction becomes equals to the rate of backward reaction. That's called the dynamic equilibrium. So if they ask you the definition of a dynamic equilibrium, make sure that you know that this is basically the definition of a dynamic equilibrium. Okay, this is the definition. The rate of forward reaction is equals to the rate of backward reaction. In dynamic equilibrium, the concentration of reactant and product become constant because the rate of formation of product and the rate of decomposition of product is same in a dynamic equilibrium. ठीक है? बिल्कुल देखिए why it is called a dynamic equilibrium. What is the basic concept of equilibrium? देखिए equilibrium is something when the net change is zero, and dynamic means it's something is moving. Now the chemical reaction doesn't stop here. ठीक है? If you look at this reaction, doesn't stop here. It going in a forward direction as well, is going in a backward direction as well. But the speed by which the product is forming is the same speed by which the product is getting decomposed. Okay, so it means that it seems like there's no net change. अब कोई तब्दीली नहीं आ सकती इसमें, ठीक है? And as I said, कि Haber's process में only 17% ammonia is formed and you have a dynamic equilibrium. You can't get more than 17% of NH3 when you have a closed system. Okay, you have to open the system, and when you open the system, then it will move in a direction to regain the equilibrium. Means if you have a chemical reaction which is a dynamic equilibrium, and you disturb that equilibrium by any physical change, like by changing concentration, pressure, temperature, the equilibrium will respond in a way that it always try to regain the equilibrium. Okay, जब भी आप equilibrium को disturb करेंगे, it always try to regain the equilibrium, and that concept is basically called the Le-Chatelier's principle. So next is the Le-Chatelier's principle. Okay, Le-Chatelier's. A statement is quite simple. If the system is a dynamic equilibrium, is disturbed, it always try to regain the equilibrium. Okay, it always try to regain the equilibrium. That's basically the statement for the Le-Chatelier's principle. And on the basis of this statement, we study the factors that affecting dynamic equilibrium. ठीक है बेटा, so reversible reaction की definition, yes, they do ask in exam. Dynamic equilibrium definition, yes, and the Le-Chatelier's principle, ये तीनों चीजें exam में पूछी जाती हैं. These are the recalling stuff. You have to rewrite it as it is. Clear? So factor affecting dynamic equilibrium, the first factor that can affect a dynamic equilibrium is basically the concentration. Okay, just to remember the effect of concentration, याद रखिएगा एक बात कि सिस्टम हमेशा always move from excess towards deficiency. ठीक है, सिस्टम हमेशा मूव करेगा एक्सेस से डेफिशिएंसी की तरफ. ये एक स्टेटमेंट आपको याद रखना पड़ेगा. क्लियर? Now, if you have a chemical reaction in which you have A plus B forming C plus D. This is a chemical reaction and it's clear that it is a reversible reaction. Okay. If you add more A and a B, if you add more A and a B, it means that you have excess of reactant on the reactant side, है ना? तो इक्विलिब्रियम किस तरफ शिफ्ट होगा? Towards product side. ठीक है बेटा? Now in a similar way, you have the same reaction, A plus B forming C plus D. And you added more C and D. So अब equilibrium किस तरफ shift होगा? Yes, you have excess on the product side and you have a deficiency on the reactant side. ठीक है? So the equilibrium will shift towards the reactant side. अच्छा, अब यहाँ एक बात और क्लियर कर दूं बेटा. Whenever the equilibrium shift towards the product side, we used to say that it's shifting towards the right hand side. ठीक है? The product side is also called right hand side. Okay? And if the equilibrium shifting towards the reactant side, so we call it the equilibrium shifting towards the left hand side. So whenever you add more reactants, so there are two ways by which you can shift the equilibrium towards the product side. Either you add more reactant or remove product. Okay? So यही बात अब हम स्टेटमेंट की फॉर्म में लिख लेते हैं. I hope this point is clear. सही है? So आप लिखिए स्टेटमेंट बेटा ऑन statement that to shift equilibrium towards product side, either add more reactants or remove product. Okay, so I hope now you can explain the effect of concentration. It's exactly the same as it was in O levels. ठीक है, बिल्कुल वैसे ही वही concept है. The system always move from excess towards the deficiency. So if you have to shift the equilibrium towards the right hand side or towards the product side, you have two options. Either you add more reactant or you can remove product. In both ways, you creating a deficiency towards the product side, and because of which the equilibrium shifting towards the right hand side. आसानी. ठीक है? Second part, effect of pressure. Now, first key point, the effect of pressure is only for gases. We cannot apply this effect of pressure on liquids. Okay? So this concept is only for gases. The statement is quite simple. Again, if you have a chemical reaction, let's take the same reaction N2 gas plus 3 H2 gas forming 2 NH3 gas. Okay? how many total number of moles or number of particles, yeah, stoichiometric ratio on the left hand side is 1 plus 3 is equals to 4. You have 4 moles on the reactant side and you have 2 moles on the product side. And we all remember it from the O levels. On increasing pressure, the equilibrium shift from higher mole side towards the lower mole side. ऐसा होता क्यों है? Why this is happening? देखिए, इस पर्टिकुलर रिएक्शन में if the reaction, गौर से देखिएगा स्क्रीन पे, if the reaction goes in a forward direction, now you can see more number of particles getting converted into a less number of particles. है ना? Can I say that when the reaction goes in a forward direction, the pressure of the system decreases because the pressure depends on number of particles. और आपके बहुत सारे particles यानी 4 particles 2 particles में convert हो रहे हैं. ठीक है ना? तो नंबर ऑफ पार्टिकल गेटिंग डिक्रीजेस क्योंकि वो एड अप होके अमोनिया के मॉलिक्यूल्स बना रहे हैं ना. नंबर ऑफ मॉलिक्यूल्स आर गेटिंग डिक्रीज. So can I say that going in a forward direction, the pressure decreases. In a similar way, going in a backward direction, अगर हम इस डायरेक्शन में बात करेंगे, so 2 number of particles are getting converted into 4 particles, यानी 2 molecules decompose होके कितने में break हो रहे हैं? 4 में break हो रहे हैं. So can I say that if the reaction goes in a backward direction, the pressure increases. ठीक है, ये तो सिस्टम खुद रिस्पॉन्ड कर रहा है. अब ये बात बताइए कि इफ यू इंक्रीज द प्रेशर ऑफ द सिस्टम, आपने बढ़ा दिया, उस इंक्रीज इन प्रेशर को वापस से डिक्रीज करने के लिए इसे राइट साइड पे जाना चाहिए, लेफ्ट साइड पे. आप बढ़ा रहे हैं, सिस्टम ने डिक्रीज करना है दोबारा ताकि टू रीगेन द इक्विलिब्रियम. आप बढ़ाएंगे, ये मोर नंबर ऑफ पार्टिकल से लेस नंबर ऑफ पार्टिकल में जाएगा, उसे दोबारा से डिक्रीज करेगा टू रीगेन द इक्विलिब्रियम. दैट्स बेसिकली द कॉन्सेप्ट ऑफ equilibrium, and that's why on increasing the pressure the system will goes in a direction where you have less number of molecules to decrease the pressure again to regain the equilibrium. आप बढ़ा रहे हैं, system is trying to decrease it to regain it. आपने कम किया, system less number of moles से ज्यादा number of moles की तरफ जाएगा और वापस से उसे increase करके equilibrium regain कर लेगा. अब बात समझ आई कि why you always say that on increasing pressure the equilibrium shift from higher number of moles towards the lower number of mole side because you're increasing it and system is trying to decrease it. ठीक है? So यही स्टेटमेंट हम देते हैं यहां पर. On increasing pressure, the system will move from higher mole side towards lower mole side. ठीक है? Higher mole side towards the lower mole side. ठीक है? This is basically the concept of and vice versa on decreasing pressure, it moves from lower mole side towards higher mole side. ठीक है? सो प्रेशर का इफेक्ट, आप प्रेशर इंक्रीज करेंगे लोअर मोल से हायर मोल की तरफ. लेट्स सपोज यू हैव हायर मोल साइड हियर and this is a lower mole side. Yes. आज लेट हो गया था थोड़ा. प्रेशर इंक्रीज करने पे हायर से लोअर की तरफ एंड लोअर टू हायर ऑन डिक्रीजिंग प्रेशर. ठीक है नी? So I hope के this concept must be clear. Let's quickly cover up the next one third, sorry, which is the effect of temperature. Effect of temperature. ठीक है, done. Shall we move forward? Okay. Now, for any reversible reaction, let's suppose again the same A plus B forming C plus D. Let's suppose the overall enthalpy change of this reaction is negative. This is an exothermic reaction. Okay? Overall, the reaction is an exothermic reaction. So, the overall enthalpy change of a reaction is basically the enthalpy change of a forward reaction. Okay, so for this reaction, as the overall enthalpy change is negative, forward reaction is negative. And the backward reaction is basically positive. Okay? And that's why the equilibrium is attained in a closed condition. कि जितनी energy forward reaction release कर रहा है, the same amount of energy is absorbed by the backward reaction. Energy must be balanced. Otherwise, the excess amount of energy must go either out of the system या आपको provide करनी पड़ेगी. दोनों conditions में the system is not a closed system. ठीक है? So key point क्या है? The overall enthalpy change of a reaction is basically the enthalpy change of a forward reaction. Let's suppose the forward is minus 100, the backward should be plus 100. Okay, forward reaction में minus 100 की energy release की, the backward reaction should absorb the entire total की total 100 kilojoules of energy. And same, अगर forward positive है तो backward negative होगा. ठीक है, clear? And एक बात और याद रखिएगा, वो ये कि if you have endothermic reaction, अभी हम enthalpy पढ़ के आए, if you have an endothermic reaction requires high temperature. Agree? यही होता है ना? और दूसरा exothermic low temperature. So on increasing temperature, the equilibrium will shift towards endothermic side. ठीक है बेटा, अब मुझे बताइए इस रिएक्शन में फॉरवर्ड शिफ्ट होगा बैकवर्ड शिफ्ट होगा? इस बैकवर्ड शिफ्ट होगा बिकॉज द बैकवर्ड इज एंडोथर्मिक. क्लियर? In a similar way, on decreasing temperature, the equilibrium will shift towards exothermic side. ठीक है बेटा? Means if you have a reaction N2 plus 3H2 forming 2NH3, delta HR for this reaction is negative, means the forward reaction is negative, the backward is positive. So on increasing temperature, the equilibrium will shift towards लेफ्ट हैंड साइड, है ना? रिएक्टेंट साइड पे शिफ्ट होगा. ऑन डिक्रीजिंग टेम्परेचर द इक्विलिब्रियम शिफ्ट टुवर्ड्स राइट हैंड साइड. ठीक है? और इसका रीजन लिखना होगा. वो आपसे पूछेगा कि रीजन लिखिए, तो आप रीजन लिखेंगे एज द फॉरवर्ड रिएक्शन इज एक्सोथर्मिक और एज द बैकवर्ड रिएक्शन इज endothermic. You have to write down the reason as well. ठीक है? So this is the effect of temperature. And quite easy, O levels based question है. ये पूरा topic उसी तरह का है. Number 4th and the last one is the effect of catalyst. Effect of catalyst. A one-liner statement. No effect of catalyst on the position of equilibrium. On the position of equilibrium. Catalyst only helps to attain equilibrium early. देखो इक्विलिब्रियम आएगा तो आप बाकी फैक्टर चेंज करेंगे ना, ठीक है? तो ये सिर्फ आपको हेल्प आउट करता है टू अटेन इक्विलिब्रियम अर्ली. By equally speeding up the rate of forward and backward reaction. Again, catalyst has no effect on the position of equilibrium. It only helps to attain equilibrium early. It speed up the rate of forward reaction and backward reaction equally. Why adding catalyst is so important? Because catalyst add करने से equilibrium early attain होगा. And when you get the equilibrium, then you can change the concentration, change the pressure, change the temperature to shift the equilibrium towards product side, and you start getting more and more product. Okay? So these are the factors at which can shift the equilibrium towards either side. So these are the factors affecting the position of an equilibrium. Next one is basically the equilibrium constant. We're going to do it in our next class.